The days when you absolutely needed a computer science degree, just to automate some basic task, those days are really fading. It's a pretty profound shift, actually. Today, we're doing a deep dive into a platform that I think really embodies this change, the ChatGPT Agent Builder. It lets pretty much anyone build these sophisticated AI helpers using, well, just visual blocks and an idea.
Welcome. Yeah, our mission today is to really unpack this thing, get to the core of how it works, and the tool itself. It's a platform for creating smart, task-specific AI assistants, these agents, without touching a line of code.
Okay, so just for clarity then, define AI agent for us quickly. What is it, really?
Think of it like a highly focused digital employee. Basically, smart helpers designed to automate very specific tasks, and they operate purely based on the rules you give them.
Perfect. So the plan today. First, we'll look at the basic logic, the blueprint, using some examples. Then we'll actually walk through building an educational agent step by step, one with multiple paths. And finally, we'll look at how you connect these agents out to other apps, like Gmail or Shopify. All right, let's unpack that blueprint. The tool sounds really accessible, but, accessibility isn't the same as it being easy to design something good. What's the actual biggest hurdle here?
It's almost always conceptual, actually. I mean, the technical part. It's practically zero now. But your ability to clearly define the problem, the instructions you write, they have to be absolutely spot on, really specific for the agent to work reliably.
It sounds incredibly powerful, but the mechanism you described, it's kind of like stacking Lego blocks almost.
That's a perfect way to put it, yeah. If you can sketch out a simple flow chart, you can build an agent. Each block does one job. Maybe it collects data, searches the web, makes a decision based on a rule. You just connect them together to get the workflow you need.
And getting started, people need to go into the OpenAI workspace, set up payment for usage first.
That's right. Yeah, that's just to cover the computing resources the agent uses when it's running. Once you're in, you see the blocks on the left and this main canvas, the workspace, where you arrange everything.
Okay, so if the tech barrier is basically gone, and the main challenge is being clear in your thinking, what's the limiting factor then? Is it really just how well you understand your own process?
Yeah, essentially. Your instructions must be absolutely clear for the agent to work well.
That clarity piece leads nicely into agent logic, how these things actually make decisions. It feels like we're moving away from general chat towards something more structured.
I like your idea of a complex agent being like a small, really specialized team.
Exactly. Take the planning helper agent example they give. It kicks off with a start trigger that's just the moment the user submits their request, like ringing a doorbell.
Then you've got the triage agent.
Yeah.
The information gatherer, right. Its only job is grabbing all the key project details right away. Right. And then comes the condition check. This is the kind of the smart bit. It asks a simple yes-no question. Do I have all the info I need? If it's yes, yes, okay, proceed to planning. If it's no, it might loop back or trigger another agent, like a get data agent, to ask for what's missing. So you see branching logic based on the data flow.
The customer service agent example is another good one for branching. The first agent just figures out the intent. Is this person trying to return something? Cancel. Just get info.
And that intent immediately dictates which specialized agent takes over. The return agent, the retention agent, whatever it is. But here's maybe a question. Doesn't using multiple specialized agents potentially add latency or cost compared to just one big, smarter model?
That's the interesting trade-off, isn't it? By using these specialized agents, you can actually assign different types of AI models to different parts of the job. A simple sorting task doesn't need the most powerful, most expensive AI.
Precisely. You use the big guns, maybe like the latest GPT model, for the heavy lifting, complex reasoning, writing nuanced text. But for the simple stuff, like basic classification or sorting, you program it to use the faster, much cheaper models, like maybe GPT 4.1 mini or something similar. You trade a tiny bit of setup complexity for potentially huge savings on running costs.
So the agent essentially knows whether to use the cheap, fast AI or the more powerful one based on the task it gets handed from that branching logic.
Yeah, the intent dictates the model choice, optimizing for cost.
Okay, let's simplify for a second and actually build something, or at least walk through it. Yeah, multi-path AI learning helper agent you mentioned, the one that sorts user questions.
Right, so step one, start trigger. We set that to text input because, well, the user's typing a question. Simple enough.
Step two is the sorting agent, the classifier. Its job is to read that question and slot it in one of maybe 4 buckets: AI news, AI tool info, AI basics, or AI business ideas.
And this brings us to a really crucial technical point. Structured output. You have to instruct this agent very specifically to output its decision in JSON format. It's kind of mandatory for reliable flow.
Why JSON, though? Why is that specific format so important? Can't the agent just, output text saying category AI news?
Because the next block in the chain, the conditional logic block, it needs something unambiguous. It can't easily or reliably parse natural language, which can be fuzzy. JSON-like category A news forces a clean, machine-readable structure. It removes the AI's creativity for that specific step, making the output totally predictable, which is essential for the workflow stability.
Okay, that makes sense. It guarantees the next step gets exactly what it expects. Which leads right into step 3, conditional logic. This is the traffic cop, basically, taking that precise JSON output and sending the request down the right path.
Exactly. And each path leads to its own dedicated, super specialized agent with really specific instructions, like the AI news agent. It must use web search, it must find the 5 most important stories from the last week, and it must give you the headline, a short summary, and the source link. Very precise.
The constraints are definitely key there. And the AI tool agent, it has to use web search too, explain the tool, but also give 3 real concrete examples of how you'd use it to actually create something, not just theory.
Then you've got the AI basics agent. The instruction here is cool. Explain things like a patient 8th grade teacher. Use everyday words, zero jargon. And this one doesn't even need web search access.
And finally, the AI business ideas agent. Find 3 successful business ideas using AI right now. Explain how AI is used and give a real company example for each.
Whoa, I mean, just imagine the precision needed for that one conditional block to reliably route, I don't know, maybe billions of queries over time, purely based on those instructions feeding it clean JSON. That's real operational scale right there.
So going back to the instructions for those final agents, why do they need to be so specific about the output format and even the style, like the 8th grade teacher part?
Yeah, that specificity stops you from getting vague, unhelpful answers. It ensures consistency, which is really important for the person using it, the end user experience. Mid-roll sponsor read provided separately.
Okay, let's power this up. Building the internal logic is one thing, but making these agents truly useful often means connecting them to the outside world, right?
Absolutely. And that's where MCP comes in, Model Context Protocol. Think of it simply as the secure handshake that lets these agents talk to external apps and services, stuff outside the OpenAI environment.
So the agent is smart, but it's kind of stuck in its box until you use MCP. How does that work securely?
MCP is the bridge. It enables connections to things like Gmail, so it can read or send emails, Google Calendar for scheduling, e-commerce platforms like Shopify, payment processors like Stripe, and maybe most powerfully, Zapier, which connects to literally thousands of other apps.
Wow, okay. That unlocks some seriously advanced possibilities then.
Totally. Like that email replying agent example. It could read incoming emails, use its logic to sort them, maybe urgent, needs review, just a notification, then draft detailed replies based on rules you set, and either send them automatically or just save them as drafts for a human to quickly check.
Okay, but hold on. If we're giving an automated agent access to read and write in my Gmail or see my Shopify orders, what about security? Governance? That seems like a big step.
That's a super critical question. And the system is built with that in mind. It requires very specific scoped permissions for every connection you set up. You have to think about that governance layer up front, setting rules that stop the agent from doing things it shouldn't. Like you wouldn't want your customer return agent to suddenly be able to read HR emails, right? So you define those permissions carefully before you let it run wild.
Let's circle back to instruction clarity, because honestly, that feels like the hardest part for me too. I still wrestle with prompt drift myself sometimes. Getting instructions concise, but also completely unambiguous.
Yeah.
It's way harder than it sounds.
Oh, I agree. It's a common struggle that vulnerability is real. It's the difference between a bad instruction like help with emails, which is useless, versus a good one. Read incoming customer support emails, identify the core problem described, write a friendly and empathetic reply under 100 words, and then update the CRM record to resolved. That specificity is the design work.
And you mentioned model choice earlier. That's critical too, for performance, but also cost, right?
Absolutely crucial. Use your top-tier model, maybe GPT-5 when available, for the really tough reasoning or generating complex creative text. But for simple sorting, classification, data extraction, stick to the faster, much cheaper models like GPT 4.1 Mini. If you build an agent that's inefficient, maybe it loops unnecessarily or defaults to the expensive model for everything, you'll see those costs spike really fast.
So if things do go wrong, the agent breaks, gives weird answers, or it's just Slow. What are the quick troubleshooting checks?
First place I'd look is often the conditional logic, the if-then stuff.
Hmm.
If it's giving wrong answers, reread those rules carefully. Maybe the intent classification is slightly off. If it's just not answering, check your block connections are solid and make sure it's actually published. If it's slow, try reducing how much it relies on web search or swap in a faster model for simpler steps.
If someone's just starting out, building their very first simple agent, what's the single most important thing they should do right after building it?
Test it with weird inputs. Seriously. See how it handles unexpected questions, confusing language, or maybe missing information. Always anticipate how users might break it.
Okay, let's bring this all together. The really big idea here seems to be this. Democratization, maybe? The power to build sophisticated tools isn't just for coders anymore. It's accessible to, the business designer, the process owner.
Exactly. And the
Uh,
practical uses are just huge. Personal research assistants, automated customer support flows, content strategy helpers, even sales assistants that could help qualify leads or schedule demos.
And that final piece of advice from the material really resonates. Start simple. Pick one clear, well-defined job for your agent. Test it like crazy. Then and only then, start adding more features of complexity.
Yeah, so the challenge to you, the listener, is maybe open up the builder, find that one repetitive, maybe kind of boring task you do often, and try automating just that. That's where you'll likely see the quickest win.
Which leaves us with a final thought, something to maybe chew on. Perhaps the biggest value of this agent builder isn't just that it makes automation easier, but that it forces us, maybe for the first time for some processes, to really define and understand the tasks we should be automating in the first place.
What hidden inefficiencies in your own work are you ready to uncover? Outro music.